Let's look at another addition algorithm. This one's called the left to right algorithm, and it requires something that we're going to refer to as partial sums. Now, technically, the expanded algorithm also requires partial sums. The standard algorithm requires something slightly different than partial sums, but sometimes it's referred to using it as well. This algorithm demonstrates that we do not have to add starting in the ones place. Now, in the standard algorithm, we do add starting in the ones place, but we don't have to. In fact, if we wanted to, we could start by adding in the hundreds place. In this case, that would be 500 plus 700. 500 plus 700 is 1200. Then we could move on to the tens place. That is a 6 and a 5, otherwise represented as 60 plus 50. 60 plus 50 is 110. And then lastly, we look at the ones place, 8 plus 7. 8 plus 7 is 15, so I write 15. When I add all of these partial sums, it's important to make sure that we're adding the digits that are in corresponding place values. So from 1200, 110, and 15, I need to add up all of the units places first, so I get 5. Then I'll add up all the digits in the tens place, so 0 plus 1 plus 1, that's 2. Then adding up the units in the hundreds place, I have 2 plus 1, which is 3. And then I have 1 in the thousands place. So using the left to right algorithm for addition, I get 1,325. We can do that same thing using the standard algorithm. We'll get the same answer. But I can't start from left to right. Here's why. If I did 5 plus 7 and I got 12, what would I do to carry over the unit? I couldn't. So I would write it maybe as 12 here, where 2 is in the hundreds place, 1 is in the thousands. Then I could try and add my tens unit. 6 plus 5 is 11, we said, but I can't write 11 here. I would need to carry my 1 over. But I've already added everything in the hundreds place, so this 1 would not get used. So I'm not able to use left to right on the standard addition algorithm. Instead, I would have to do it right to left. So starting with my units place, I would do 8 plus 7 to get 15, carry my 1. 1 plus 6 plus 5 is 12, carry my 1. 1 plus 5 plus 7 is 13, and I get the same answer. Again, the standard algorithm leaves a lot to the imagination. There's nothing here that really shows me how this process happened, unlike this left to right algorithm where steps are shown very clearly. This is where I'm getting each of the numbers. It's less magic and more math.